Okay, let's do problem 3 on the practice final. It is another polynomial question. And so it says, consider this wonderful polynomial, and A is give all zeros and their multiplicities. Okay, so basically we need to factor this polynomial. That means we need to know what its roots are. It's a cubic. If it were a quadratic and that were 2, then we would just use the quadratic formula, but we don't use the cubic formula. Where do we begin? We have to guess the first root, okay? But we don't have to just guess anything because we have the rational roots test. So the rational roots test says that if something is a rational root of this polynomial, then it's going to be p over q, where q divides this leading coefficient, which is 1, and p divides this last coefficient, which is 15. So since q is 1, I don't really need to worry about it. I just need to think about this 15 here. And so what are the possibilities? Plus or minus 1 divides 15, plus or minus 3 divides 15, plus or minus 5 divides 15, and plus or minus 15 divides 15. And so let me just start checking these things with synthetic division. So let me check 1 first. And I'll write the coefficients of the polynomial here. Okay. 1 comes down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Negative 13 plus negative 2 is negative 15. 1 times negative 15 is negative 15. And I get 0, and I got lucky. I hit the jackpot. And that tells me that x minus 1 is a factor of this polynomial. Okay. So that means that the whole thing can be written as x minus 1 times the stuff that's left, right? These things tell me the coefficients of what's left. So what's left is x squared minus 2x minus 15. Okay, and so I want to factor it the rest of the way, so I ask myself, can I factor this? Of course, I could just use the quadratic formula if I had to. But let me try to do it in my brain first. I need to think of two numbers that multiply to negative 15 but add to negative 2. And I say, and then my brain returns the answer, negative 5 and positive 3 work. And so the polynomial can be factored as x minus 1, x plus 5 times x minus 3. Sorry. I did that the wrong way. It's x minus 5, right? Minus 5 and x plus 3. Okay, so I have this. It's the same as that polynomial there. And so now all I have to do is graph that thing, which is very easy. It's degree 3, right? And it has a positive leading coefficient, so I know that its end behavior is just kind of like this. Alright, and I have a date with a root at negative 3, and let me add some fun colors, and another root at 1, and another root at 5. Okay, and these are all multiplicity 1, so that means I'm just going to go through each of those roots. So what is my y-intercept? Need to put that on there too. This is the y-intercept. This is what comes out when you plug in 0. It's it's positive 15. Okay, so here is, it's really kind of out of scale, but I'm going to put 15 right there. Alright, and so here I go. So go through, go through, go through, go through, and I'm done. That's it. That's the shape. It's a lovely cubic shape. Alright, anything else? I guess, yeah, that's it. Okay, alright, bye.